This time we are going to analyze parallel RC circuit. We're supposed to find Z total. In order to find Z total, I'm supposed to find the impedance of the capacitor first. The formula for impedance of the capacitor says Z of C or X of C, this is equal 1 over omega C, where my omega is equal 1 times 10 to the 6 radians per second. So F1 divided by, this is my omega, 1 times 10 to the 6 radians per second times the capacitance of the capacitor, 10 nanofarads. This is equal 100 ohms and angle of negative 90 degrees. You're supposed to remember that anytime we talk about the impedance of the capacitor or capacitive reactance, we're supposed to always have the angle negative 90 degrees next to the magnitude or value of my impedance of the capacitor, of course. Next, in order to find Z total, I'm supposed to use product over the sum. So I have Z total is equal R times Z of C over R plus Z of C. Okay, why? Because I have just two components connected in parallel. That's why I'm going to use the product over the sum. So if R equals 250 ohms times impedance of my capacitor, which is equal 100 ohms and angle of negative 90 degrees over 250 ohms plus 100 ohms angle of negative 90 degrees. Use the calculator. You're supposed to obtain the value of 92.84 ohms and angle of negative 68.19 degrees. Okay, this is the value of my total impedance. Next, we're supposed to find the total current. In order to find total current, you're supposed to realize that right now we talk about the voltage source and the total impedance. Okay, so I can redraw my circuit like this right now because I found ZT. So in order to find the total current, I'm supposed to use Ohm's law. I total is equal voltage source over Z total, where voltage source is equal 10 volts, of course peak, because this is the magnitude, so I have 10 volts peak over Z total 92.84 ohms and angle of negative 68.19 degrees. This is equal 107.71 milliamps and angle of 68.19 degrees. This is my total current. Next, I'm supposed to find the current which goes through the resistor. Please notice that when we talk about the parallel circuit, we have the same voltage across each component. So voltage source is going to be equal to voltage across the resistor, and it's going to be also equal to the voltage which occurs across the capacitor. So I'm supposed to say that voltage source is equal VR and is also equal VC. Why? One more time, because we talk about the parallel circuit. So IR is equal VR over resistance, where VR is equal 10 volts and angle of 0. Okay, this is my 10 volts and I have no angle, that's why I can ignore this 0 or I can add this 0, it doesn't matter, over resistance. Resistance is equal to 250 ohms. This is equal 4 milliamps. This is my current which goes through the resistor. Next, I'm supposed to find the current which goes through the capacitor. Okay, so I'm going to write over here IC is equal voltage across the capacitor over the impedance of the capacitor, where voltage across the capacitor we said is equal to the voltage source, which is equal to 10 volts, over Z of C, which is equal 100 ohms, and angle of negative 90 degrees. This is equal 100 milliamps and angle of 90 degrees. This is the current which will go through the capacitor. And someone can say, okay, we can continue and we have to find, let's say, voltages and powers. But before you are going to continue, it's always good to check if these two answers are correct. You're supposed to apply KCL, Kirchhoff current law, to verify these two answers. What I mean by that? You're supposed to realize that I total is going to be equal to the sum of these two currents. I mean IR plus IC, where IR is equal 40 milliamps plus IC equals 100 milliamps and angle of 90 degrees. If you are going to add these two currents, you're supposed to obtain 107.7 milliamps and angle of 68.19 degrees. Now you're supposed to compare this answer with this one. As you can see, they are almost identical. Okay, I'm not going to look at this one, so basically we can say that they are identical. So far we are okay. Next, the problem is asking me to find VR and VC. We said already that VR and VC is equal to the voltage source. So these voltages are equal 10 volts and angle of 0 degrees, because this is parallel circuit. Next, we're supposed to find the true power, P. Okay, so P is equal, because I'm dealing with the peak voltage, so if I have peak voltage, I found also peak current, right? So I'm supposed to use the formula 1/2. I can use the formula with current, which says IR square times resistance, which is 1/2 IR, which is equal 40 milliamps to the second power times the resistance, which is equal 250 ohms. Okay, use the calculator. You're supposed to obtain the value of 200 milliwatts. Okay, this is the true power in my circuit. Next, I'm supposed to find the reactive power, okay, QC. So I have QC is equal 1/2 IC squared times Z of C, which is equal 1/2 and the current which goes through the capacitor is equal 100 milliamps to the second power times Z of C, and we found that Z of C is equal 100 ohms. This is equal 500 millivolt ampere reactive. This is the reactive power in my circuit. Next, I'm supposed to find the apparent power. S is equal 1/2 I total squared times Z total, which is equal 1/2, and my total current is equal 107.71 milliamps to the second power times Z total, which is equal 92.84 ohms. This is equal 538.53 millivolt amp. And this is the value of the apparent power. Next, we're supposed to find the power factor. Formula for power factor says power factor is equal cosine of angle theta. So I have cosine of angle negative 68.19 degrees. This is equal 0.371 lead. Why lead? Because current total is leading the voltage source by certain angle, by basically this angle 68.19 degrees. So that's why I'm supposed to use word lead. Next, I'm supposed to find the equivalent series circuit. Okay, means I have to convert this parallel circuit to the series circuit, which is going to have exactly the same impedance. So what I'm supposed to do in this case? I'm supposed to take the value of Z total. Okay, and in this case, my Z total was 92.84 ohms, and angle of negative 68.19 degrees, and convert this polar form to rectangular form. So I'm going to have conversion to rectangular form, and I have 34.49 ohms. This is the value of my resistor in series circuit, and I have negative J 86.19 ohms, and this is the value of my impedance of the capacitor in the series circuit. Now I can draw the series equivalent circuit by simply drawing the voltage source, resistor, and capacitor in series. So this is my voltage source, and this is my RS, and this is my Z of CS, where RS is equal 34.49 ohms, and Z of CS is equal 86.19 ohms, and voltage source is equal 10 sine 1 times 10 to the 6 T and volts. Okay, so at this moment I can say that the problem is solved.